Hey everybody. So this video is going to be another one in the series about mathematical communication and practice. And this one in particular is going to be about graphs. So as I've said at the beginning of all of these other videos, the IB guide gives us some general guidance on what they're looking for in terms of mathematical communication. They want appropriate mathematical language, they want definition of key terms and variables, and they want us to use multiple forms of mathematical representation. The trouble is that the IB guide doesn't actually give us any guidelines about how to use graphs, tables, charts, formulas, diagrams in mathematical writing. And so the purpose of this video and any of the others that are in the series are sort of about what things to look out for when you're working with graphs. So the first thing I want to mention, this is probably fairly obvious, but just to sort of point out, the purpose of a graph is to provide a visual representation of a relationship between two quantities. So if you have two variables and you want to show your reader the relationship between those variables, a graph is a great way to go. The reason that I like to talk about what the purpose of these things is before we sort of get into how to use them is I don't want you to just use a graph because it feels like the thing you should do. Your graph should be there for a purpose. There should be a reason that it's there. And the reason should be more than just, well, I need to have multiple mathematical representations, so I guess I better put other stuff in. So the purpose is to give your reader a visual representation of the relationship. So now with that said, I want to get into some general comments and guidance about the use of graphs and how to include them, how to write with them. So arguably the most important thing about graphs is that they be readable. This means that you need to have axis labels, you need to have units, you need to have scale, and all those things need to be readable. In addition to that, you want the size of your graph to be appropriate. You want people to be able to see it and for it to feel good and natural in your paper. And I didn't put that in here. Actually, maybe I'll get to that point later. First thing I want to say about this idea of graphs being readable, if whatever software you're using to do your graphs won't let you increase the size to readable levels, in other words, if whenever you format the graph, the text always ends up being really small and you can't figure out how to do it, it's okay to write that in by hand. It's okay to print that graph out, write them in by hand nicely, and then take a picture, scan it, and then put that into your document. So the other thing I want to mention about labels, units, scale, is this idea of there's some connection between this and the idea of defining variables. You want to make sure that the labels on your axis are clear and complete. And you'll see a bad example of this below when we get to it. But as an example, suppose that your vertical axis on your graph was tracking like the amount of ammonia in a 5-gallon aquarium measured in parts per meter. You could label the axis ammonia parts per million, not meter, and then give more detail about that variable in the paragraph before or after the graph. So please don't feel like you need to write the amount of ammonia in a 5-gallon aquarium measured in parts per meter all on the axis of the graph. It's okay to just put ammonia ppm. I said parts per meter again, parts per million. But then in your paragraphs around it, describe more of what's going on with that graph. I'll get to it later. Graphs are supposed to fit into your document. But it's okay if the graph doesn't have everything in it, as long as the paragraphs around it make that graph really clear and easy to read. Another really important thing, and it's a little bit harder for some students to understand sort of what this means and what to do with it. When you're graphing, you need to pay attention to whether the points on your graph should be connected. Oftentimes computer graphing programs like Excel or Google Sheets will default to a line graph where if you've got 5 points, they'll connect all the points. That might be okay, but often in math, we don't want that to happen. We just want to look at the points. Or maybe we've got a bunch of points and we don't really want to see the points as much. We want to see the curve that fits them. You need to pay attention to what you want your graph to communicate and whether you want points or whether you want connected, whether you want to see the points or whether you want to see, the best fit curve. So pay attention to what your graphing program is doing, and if the output isn't giving you what you want, change that output. You're getting points in your exploration for including mathematical representation like a graph, but to score really well, you want your graph to communicate as well and as accurately and as completely as possible. I say this for all the videos in this series, but I'm going to mention it here as well. Your graphs need to fit into the flow of the document as a whole. You're writing a math paper, and that means that your purpose is to explain what you're doing and show that to the reader, help them to understand what you're trying to say. Graphs can be really powerful tools for that, but they have to be included in the paper. And that means you don't just want to say, here's a table, here's that table represented as a graph, and I'm done. Like, you really should have a paragraph before, after, around, near it, talking about what, in this really leads into the next thing here. You need to explain your graph. What do you want people to see? What's it there for? What's the purpose? And honestly, that's what I'm saying here is getting into the other criteria, but it also shows that the criteria kind of linked together. It's hard to have good, appropriate mathematical communication if you're not also using words to explain what's going on. And then the last thing, and this is true for all of these types of things, when possible, try and keep your explanations or references to a graph on the same page as the graph. If it's absolutely necessary, if you've got a lot to say, that's fine. You can go on to the next page. But you really don't want to do, here's a table, as you can see in the graph below, and then the graph is on the next page. In your proofreading, you really want to go through and make sure that all of these things are communicating well and appropriately. So now that we've got sort of this general guidance about graphs out of the way, I'm going to go through and get into sort of 2 examples. Normally I do 3. I'm not sure why, but this time I really just kind of felt like going straight from, bad, incomplete example to complete, better looking example of how we would use graphs for mathematical representation. So suppose that you were doing exploration about population growth in the United States in the 19th century. Not what I'd want to write an IA about, but it's the data that I found. So here's what we got, right? So suppose that this was in your IA, right? Or a student included this in their IA. They said the table below gives the US population in millions at the start of each decade. And then there's a chart, there's a little table there that gives the year and the population. And then they said the data can also be graphed. And then there's this graph here. And then that's it. By the way, I made this graph in Google Sheets. I entered all of this information into 2 columns, and then I went and did like the chart option, and it gave me this chart. Like, this was the first thing that came up. I had to click a couple things. No, actually, I don't think I did. This kind of came up right away, and so this was sort of me showing like a low effort, like, oh look, I made a graph. So what's done well? What could be improved? So in terms of things that are done well, the axes were labeled. It does say population in years, but there's no indication on here of what the scale is. Now, technically up here, it did say the population in millions. And so, I'd probably be willing to say, okay, I can tell the population years in millions. They told me that up here above. All right, fine. But the years, it goes from 0 to 60. These were like 1800 to 1860. At that point, you're kind of going like, oh, okay, so it's probably years since 1800. I can probably infer what's happening here, but this is not communicating well. Okay. Also, the labels on the axes aren't clear or well defined. So I kind of talked about that. So there's no scale, there's no real units here. The labels on the axes aren't very clear. So yeah, there's some labeling, but even this strength is not very strong. What could be improved? The individual points can't be seen. Like the person, this IA said, hey, here's 7 data points, and then they gave me a graph of a line, and so it's kind of like this didn't communicate the way that the student wanted to. This is a graph that really should have been done as a scatter plot, as 7 points where you can see the points clearly, and then leave it to the reader and the writer to explain what the points are showing. Google Sheets can do that, but I would have needed to choose that option, and I was trying to come up with a bad example here, so bad example. The graph was completely missing a scale as well as units, so we kind of already mentioned that. Also, the text on this graph is kind of small, so it's almost like the size of population here is a lot smaller than the size. And I'm not about to say, well, you should have changed the font too. Like, we're not going to get into like nitpicky little things like that. But maybe the student felt like if I made the graph full size to get population to be the same, the graph just feels too big on the page. It's kind of a personal choice thing, but you know, for whatever reason, they shrunk the graph down a little bit, maybe to make it, maybe they wanted it to fit on the page with the description, even though there's no description here. But that made the font really small. This is not a good thing. There's also, you notice, no indication of what the reader should do with the graph. So it's kind of like, okay, I had some data, and then I did a graph. What now? Like, as a reader, you're left looking at that going, oh, there's a graph. We need more than that. So there were issues with the graph in particular here, but there were also issues with how the graph was connected to the rest of the paper, which admittedly is hard to see in an excerpt, but I'm hoping that by showing you guys this, you can get a sense for what can go wrong with graphs, or how graphs can be done poorly. So now let's look at this same data done well, or done better. So the beginning of it is really about the same thing, right? The table gives the US population in millions at the start of each decade. Boom, here we go. Then we've got this paragraph. There's a paragraph that's clearly leading into the graph. Since one of the goals of this exploration is to try to find a function that would match this growth in the 19th century, we will plot the points on a graph to see if we can determine what kind of function would best model the data. So right there, this example is setting up why I'm doing this graph. Right? We're going to see if we can determine a kind of function. On the graph below, now I'm making reference specifically to that graph, the horizontal axis will represent the number of years since 1980. Okay, gotcha. So it's now clear and explicit, and it's written in years since 1980. And the vertical axis will track the US population measured in millions of people. I gave like a full description of the US population measured in millions of people, and then on the graph, I just needed to write population in millions. For this graph, I used Desmos, which it's like actually a graphing calculator. It's designed to do this. Because of that, there are more lines on this graph. It looks more mathematical. It's easier for people to see that this number right here is, you know, if this is 20, this is 10, this is 5, so this is like 7.5-ish. And if we look up at our table, oh, 7.24. Do you see how the inclusion of more lines on this graph makes it way easier for the reader to see what's happening? And then after this, there's even more. Looking at the graph of the data above, the data appears clearly to be following an exponential trend. This leads us to the next part of our exploration, which is to meet our aim of finding an exponential function that models the growth of the US population in the 19th century. So yeah, I made some changes in the graph here. I did it with Desmos instead of Google Sheets. By the way, Google Sheets isn't bad. I think you have to do a lot of work to get Google Sheets to give you like a mathematical graph that's going to look right. So I did change some things in the graph, and that did make the graph better and communicate better. But in addition to that, adding a little bit of text before and a little bit after the graph, I hope you can see, really give it a sense that this fits into the paper. The graph now serves a purpose, and the reader's like, oh, like you've led me to think, aha, here's the points. Hey, it looks like they curve a little bit. Oh, that's exponential. Oh my gosh, that's literally the aim in your exploration. You wanted to find a model that would match this. This is now helping to meet your aim. It's adding to cohesion in your paper. So not only are you improving Criterion B, mathematical communication, by using a graph to communicate well, but in addition to that, you're adding to doing well in the other criteria. I've probably already mentioned all the things that were done well in this one, but I'll mention them really quickly here. The graphs are labeled clearly. They have units and a legible scale. The graph is now shown as a scatter plot, which is appropriate. And the text before and after the graph, oh, sorry. The text before and after the graph help the reader to understand the purpose of the graph in the context of the exploration. You know, the font on this is a better size. Even if I shrunk this down to kind of closer to the size that the other graph was, this text is still larger text than what's up above that we did in Google Sheets. Again, nothing wrong with Google Sheets, but you need to pay attention to how large, what the size of this label. Ooh, this might even look good if you did it as like a little centered graph. It's kind of nice. Anyway, there are choices that you can make, and hopefully this video gave you a sense of things that you need to be paying attention to when you're building graphs and including them in an exploration. one more thing I might mention here, the person that did this might choose, a couple of lines later or maybe a page later, once they had found their exponential graph, maybe they would then plot these points still in black. I don't know how to make my hand go that way. Yeah, there we go. And then also put on there what the graph is and show how close the points are to the graph. You could do another graph of that later. Anyway, that's getting outside of what we're talking about here. So again, hope that made sense. If you got questions, let me know. And best of luck as you keep working on being mathematical writers. See you later.